Hello everyone, this is Pradiyam Krishnan, the author of Bits, Bytes, Where, an introduction to data structures. In today's video presentation, I'm going to build upon our study of arrays from the second blog post and introduce a new data structure called linked list. It is assumed that you have taken an introductory programming class and are familiar with classes and objects. Thank you and enjoy. Let's take a closer look at an image referred to in the previous blog post. Suppose we instantiate a dynamically allocated array with 2 elements and initialize index 0 and 1 with 2 and 7. Everything looks normal. When we add a new element to the array, the size is doubled because there's no room for the third element. Finally, the third element is positioned at index 2. This example continues to add values until the array is full. Again, we double the size and add another element. But what if we stop here? The array has allocated 3 extra space than we need. Although this is not a concern for small datasets like this, imagine a large array with thousands of elements. To solve this memory issue, a new data structure is here to help. Linked list is a data structure which does not allocate chunks of data all at once, but allows the programmer to allocate memory as the program requires. A linked list starts with a head, and each element of a linked list is called a node. In this simple version of a linked list, the node is called the head, and there are 2 fields. The data field, which in this case is an integer, contains an integer value, and the next field is a pointer, which contains the address to the next node. When there is no node to the right, then the pointer is equal to null, which is represented by a slash in this visualization. When we want to add a new node to the linked list, we create a new node object and change the pointer field of the previous node to the address of the newly created node. As you can see, the slash has been replaced with an arrow which points to the newly created node. As we add more values, we create new nodes at the end of the linked list to form a long chain. The bottom data structure underneath the linked list represents how a dynamic array would look like under the same scenario. However, you may notice that we have 2 fields for each node in the linked list compared to the only 1 element in the array. So for a data structure of a known capacity, a linked list is not the most memory efficient option. But when the size is unknown and the dataset is large, a linked list can potentially be more memory efficient. Now let's see it in action. I will be using Visual Studio Code to demonstrate. The node structure is represented in node.java. There are 2 variables, value and next. Value is of type T, which is a generic type and can be used to represent any type, such as integer, string, etc. The next variable is of type node, which represents a node structure. This will store the pointer to our next node. Finally, we have the constructor. This will initialize the values value and next. Next up, we have the linked list class, which will represent our entire list. As usual, in the constructor, we initialize our global variable head, which represents the head of the linked list. In this class, we will create an append method to add a new value to the end of the list. First off, we start by creating a new node which represents the parameter value with the next pointer null. If the head is equal to null, then there are no nodes in the list. Therefore, we can directly point this newly created node to head. However, if there are nodes in the list, we will have to traverse till the last node where the next field is equal to null. At that point, we can set the next field equal to the newly created node. Finally, I have created a toString method to visualize the linked list. Finally, what you all been waiting for. Let's now test our code. I have created a new linked list object and I'm appending 5 numbers to it. There we go, our code works. That's all folks. I hope you got a brief introduction to the downsides of dynamic arrays, linked lists, and its implementation. To learn more about linked lists and other methods, be sure to check out these suggested resources. Feel free to leave a like, comment, and subscribe to my YouTube channel. Thank you and peace out.